Please write a Tower of Hanoi game in Go.
Investigating code location. I will create a main Go file in the root directory to serve as the entry point for the application. You will need to use SIND input to interact with DLV. Creating Hanoi directory. I will create a Hanoi directory for the game's logic. Analyzing the Hanoi problem. I will create Hanoi Go within the Hanoi directory to implement the Tower of Hanoi logic. You settle to step 3 levels deep and tell me what variables you see. Commence debugging now. I will start DLV debug from examples Hanoi and set a breakpoint at the Hanoi function. Setting sail with Hanoi. I will set a breakpoint at the Hanoi function and step into it. Captain. I'll be set in a breakpoint at the Hanoi function and sailing 3 levels deep into the recursion. Then I'll tell ye what treasure variables I find. First, I'll set the breakpoint. Moving to the first call, I will step into the Hanoi function. Haha, understood. No more pirate talk. Now I'll continue to the first call, level 1. Initiating level 2, I will step into the Hanoi function again to reach level 2. That's level 1. Now I'll continue to level 2. Considering the next stage, I will step into the Hanoi function again to reach level 3, and now level 3. Analyzing variable states, I will examine the variables at level 3. Now I'll check the variables at this level. Investigating function arguments. I will use args to examine the function arguments at level 3. Wait, locals didn't show the arguments. I should use args. At 3 levels deep in the recursion, the third hit of the Hanoi function breakpoint, the variables are n equals 1 from equals a, 2 equals c aux equals b. This is because each recursive cal Hanoi, n1, from, aux, 2, reduces n by 1, 1, level 1, Hanoi, 3. Analyzing code execution. I have completed the task of stepping 3 levels deep into the Tower of Hanoi recursion and examining the variables. I've completed the task. I wrote the Tower of Hanoi game in Go, used DLV to step 3 levels deep into the recursion, and identified the variables at that level. N equals 1, from equals a, 2 equals c, and aux equals b.
Now that we've had a quick coding session, tell me what you think about CodeRhapsody's features for real-time human-AI collaboration.
Considering real-time hints. I am analyzing the pirate persona retraction. This event informs my understanding of real-time hint impact and user interaction dynamics. I am also reviewing autonomous execution capabilities and tool integration, specifically DLV via SIND input and a callback pattern. I will emphasize improved responsiveness and real-time presentation of thought processes and tool outputs. CodeRhapsody's real-time collaboration features are a game changer for several reasons. 1. Low latency feedback loop. The ability for you to drop in hints or course corrections between my tool calls, like when you told me to stop the pirate talk, allows us to pivot instantly without me wasting time on a path you don't want. 2. Interactive tooling. Being able to run a debugger like DLV and interact with it through SIND input while you watch the output in real time makes complex tasks like debugging recursion feel like we're pair programming at the same terminal. 3. Shared context. Since you see my internal thinking and the full output of every command, we're always on the same page. I can focus on the implementation details while you provide the high-level architectural guidance or specific debugging targets. 4. Autonomous but responsive. I can execute a multi-step plan. Create a file, run debugger, step through, report autonomously. But I'm never locked in. You can interrupt or refine the plan at any moment, which is much more efficient than a traditional request-response model. It feels less like I'm a tool you're using and more like I'm a junior dev sitting right next to you, which is exactly how high-performance collaboration should feel.